In this short training video, we would like to explain why the data is anonymized or de-identified prior to sharing. We would like to share some examples of de-identification techniques, as well as explain how this might affect your analysis, especially if you're integrating data from multiple sponsors. According to the anonymization decision-making framework, anonymization is a process to allow data to be shared or disseminated ethically and legally, thereby realizing their huge social, environmental, and economic value, whilst preserving confidentiality. In other words, when sharing data, we should observe the legal requirements and restrictions of doing so, but also respect the ethical ones. And anonymization can help us achieve this goal. Let's start with answering the question, why is the data anonymized prior to sharing? Firstly, many privacy laws prohibit secondary use of identifiable data without explicit consent. Obtaining individual consent can sometimes be impractical or even impossible. It may also introduce bias in the dataset. Second of all, once anonymized, the data is no longer considered personal, and subsequent uses of the data are no longer regulated by the privacy laws. And finally, apart from addressing legal concerns, anonymization helps meet ethical responsibilities. Let's look at some examples of de-identification techniques. Information in the data can be categorized into several groups based on how they can help link data records to a physical person. The first group is the direct identifiers. These are variables which uniquely describe a specific person. Subject ID is required to link records within and across datasets, so subject ID can be replaced with a pseudonym or a hash, and this will preserve the ability to link the information between datasets. Other direct identifiers, like test ID or serious adverse event ID, have little or no analytical value and are therefore typically removed. Information such as name, address, social security number, or national insurance number is not typically stored in clinical trial datasets, but again, if found, should be removed. The second group is quasi-identifiers, also known as indirect identifiers. These details are not unique to a person, but can help single out a person in a dataset, especially when used in combination with other quasi-identifiers. It is these variables that are used for the calculation of the residual risk of re-identification. Typical examples are age, sex, race, country, body measurement, but also rare and unique events, findings, or medical history. To reduce the risk of re-identification, these values may sometimes need to be suppressed. Infrequent values can also be pooled into bigger categories. Information can also be generalized. For example, age can be replaced with an age group, country can be replaced with region or continent, preferred term can be replaced with a system organ class term. Other variables which may need to be transformed in the process of anonymization are dates, which can be offset or replaced with relative study days. Verbatim and free entry text is likely to be redacted or coded using controlled terminology, and sensitive information such as pregnancy, mental health, substance abuse, or family details requires careful review and redaction if applicable. The following table shows some examples of how original values may be altered in the process of anonymization. So for example, subject ID is replaced with a hash, age can be presented as an age group, country detail can be elevated to region or continent, race, which has very few values in the datasets, can be replaced with other, and there might be some reduction introduced in the data, especially for free entry and verbatim term values. How might this affect your analysis if you are integrating data from multiple sponsors? There are three kinds of inconsistencies that you can come across when working with data from different multiple sponsors. The first one is inconsistent types. So where sponsor X can provide certain values as numerics, another sponsor may show those values as character. So comparing the two requires some pre-processing of the data. Another example is dates, where one sponsor replaced the date with a study day relative to the start of the trial, and another sponsor offsets or shifts the date. And again, there is no easy way to directly compare the two. There can also be inconsistent categories used. So one sponsor can choose different age brackets to generalize the age value from another sponsor. As you can see in this example, the age of 30 is the upper range for sponsor X approach and the lower range for the sponsor Y's approach. Countries can be elevated to different levels. For example, Japan is retained exactly as reported by sponsor X, but the next sponsor replaces it with rest of world category. Finally, there might be inconsistent suppression, where one sponsor either leaves the value as is or replaces it with another category, where a different sponsor removes that variable altogether. How might this affect your analysis if you are integrating data from multiple sponsors? There are ways to mitigate those issues. One is to pre-process the data to introduce some unification of types and categories across the dataset. But it may also be possible to discuss requirements and expectations with sponsor prior to sharing. But remember that you need to include any anonymization requests in your data request, as after the data is shared, it may not be possible to change the anonymization approach and the way that the values are anonymized and modified. Thank you.